Question number 5. I would like to show you how to derive for the Sn formula. So first of all, we will start with the first three terms. A plus D, A plus 2D, and then the last, we should have the last three terms. So we want to derive the Sn formula, which is this one. Now let me show you. I'm going to show you how to derive the Sn formula. So first of all, we will add the term one by one. Start from the first term, second term, and then third term. Right, this is the third term, and in between got many terms, but we don't want to write. We want to write the first three and the last three. Alright, so I'm going to write the last three. So the last three is n minus 3d and a plus n minus 2d, and of course the last term will be a plus n minus 1d. Okay, there is a d there. Okay, so basically that is how we add lah. We have to rewrite again. Okay, our Sn, if we write reverse way, we will write a plus n. This is the last term, right? And then we have the a. I change the color. A plus n minus 2d, and then we have the another one. I use purple color, which is, no, I have to use the red color. A plus n minus 3d. Okay, we just add until the last three terms. Now should be a plus 2d, right? Plus a plus d, the first three terms plus a. So that means we reverse the last three terms to in front. Okay, here. Now I'm going to add them. So Sn plus Sn, so I have to add them. So I have 2 times of the Sn. Now I want you to focus on this one. If I add this thing, what I will get is, I will get 2a, right? A plus n minus 1d, right? If I'm going to add these two, I will still getting a plus a, which is 2a also, right? And then d, okay, I'm going to show you d plus, let's say I show you d plus nd. I explain minus 2d. You notice that this d and minus 2d become minus d, right? Minus d, right? So that means the d can be factorized out at this n minus 1, right? So finally you will get back the same n minus 1d. Got it? Okay, even the third term also, if I add the third term, this one and this one, you will get the same, which is, if you see, you have a here will be 2a, right? And 2d minus 3d will be minus 1d, and you factorize the d, you'll get this. So that is the pattern that we observe, right? So in short, if I have 3 terms, I just take this 2a plus n minus 1d times 3, right? But if I have n term, I'm going to sum for the n term. So I just take the n multiplied by this number, this thing, this pattern number. So then we can say that, we can almost show that we are getting the sum for the first n term. Because we just want the Sn, we divide by 2. So we got the formula by derive on our own. Right, this is the formula for sum for the first n term. That's all my sharing on how to derive the sum for the first n term for arithmetic progression. Question number 5. First of all, we need to take xn, sum for the first n term, plus sum for the first n term by using the first term, second term. Second term is a plus n minus 1d, and then plus the a plus d plus a plus n minus 1d plus a plus 2d plus a plus n minus 3d. This one is we take the 2Sn formula, we sum up. One is from first term, second term, third term to the last term, and we plus again, but we are taking the last term plus the second last plus the third last and plus until the first term reverse. Then we simplify. We will notice that the formula looks like this, which is every term can be simplified as 2a plus n minus 1d. So that means that Sn plus Sn is 2Sn. So if we want to find Sn alone, so we need to divide by 2 for the Sn. So it becomes Sn equal to n over 2, 2a plus n minus 1d, and hence if d is 1, we substitute. Sn is 20 over 2, 2a is a log 10k plus we have 20 term, 20 minus 1, 19 times the common difference is 1. So the answer is 20 log 10k plus 190. So this question you must know how to do proving, right? So that's question number 5.